off with an example of what we did yesterday. Are we all ready? I have the negative 10 over the square root of 200. So what's the first thing I'm going to do to simplify this? Okay, so multiply the square root of 200 into both the numerator and the denominator. So when I do that, I get the square root of 200 on top and the square root of 200 on the bottom. I multiply straight across. So in the numerator, I get negative 10 times the square root of 200 over, what's the square root of 200 times the square root of 200? Just the 200 that's underneath the square root. We're going to pause here because we are not finished. What do we still have to do? We need to simplify that square root of 200. Okay, because we can't just leave a super large radical there unless we're sure that it's prime or it doesn't have any perfect squares that come out of it. Right off the bat, is there a perfect square that I can take out of 200? Okay, let's factor tree it and find out. So I have the square root of 200. What multiplies together to get 200? 2 and 100. 2 is prime, 100 is not. However, what is 100? Perfect square, 10 times 10 equals 100. So I can rewrite this as 100 times 2. I can square root both of those. You told me the square root of 100 is 10. So this reduces to 10 root 2. So I'm going to replace the square root of 200 up here with 10 root 2. When I do that, I get negative 10 times the square root of 2 all over 200. Can I put any of that together? The tens. So I get negative 10 times 10, which is what?
Negative 100.
So I have negative 100 times the square root of 2 all over 200. And then I ask myself, can I simplify anything out of 100 and 200?
Yes.
100, right? 100 divided by 100 is 1. 200 divided by 100 is 2. So I'm left with negative square root of 2 over 2. And that's my final answer. What you thinking? Yeah. You can put negative 1 times the square root of 2 if you're more comfortable with that, but you don't need to have that there. How are we feeling about this? I see a lot of not great looks on your faces.
So this next one, I just want to do it.
The notes are all online if you need. Yeah, always. We are going to do another one because I think it could really help us to see another example. So this time I would like to do the square root of 5 over the square root of 10. What is the first thing I would like to do to try to simplify this? And do what with it? Into? Okay, so I want to take the square root that exists in my denominator and multiply it into both the numerator and the denominator so that I can cancel out the square root from the bottom. So I do that. I multiply both the top and bottom by the square root of 10, and I multiply straight across. How do I multiply two radicals together? So the square root of 5 and the square root of 10. We multiply what's underneath and put the answer under a square root. So what's 5 times 10?
50.
So this becomes the square root of 50 in my numerator. And then what's the square root of 10 times the square root of 10? 10. Now I need to reduce or simplify that square root of 50. What multiplies together to get 50? I heard 5 and 10. 5 is prime, 10 is not. What multiplies together to get 10? 5 and 2. Both of those are prime. So my prime factorization is 5 times 5 times 2. I put together like numbers, so 5 and 5 come together to become 25 times 2. Square root both of those because there's nothing else I can put together. The square root of 25 is 5, and the square root of 2 stays the square root of 2. So I replace the square root of 50 with 5 times the square root of 2, still over 10. And then my last step is to simplify the whole numbers. Is there anything I can take out of 5 and 10?
Yes.
5. 5 divided by 5 is 1. 10 divided by 5 is 2. And I get square root of 2 over 2. And I'm done. How do we feel about that? It's rough. I know it's rough.
What are we gonna, is the test gonna be like towards the end?
Yes.
Like a week or so?
Like, honestly, we might not even have a formal test over this. It might just be tested on the final.
Great.
It will not be a huge part of it, I promise.
Dude, it's December 2nd. We get out like the 20th.
We get out the 18th is the last day of finals. So 17th and 18th, and we are going to start reviewing that Monday.
So what is it, like 2 weeks?
So we really just have this week and next week.
Oh, man.
Oh my god.
Yeah.
This is the one.
Yes, my hope is to have it done by the end of the day today. It'll probably be tomorrow though.
20th.
This is
Okay.
the only class I have to pass to graduate. So
Yeah,
like,
yeah.
I can't do that, but I can help you earn the grade.
yeah.
Okay,
Let's get out.
so for the most part, how do we feel about this? For the most part, I know she's not pretty and she takes a lot of time, but is she doable? Maybe?
No. For me, yes. For everyone else, I don't know.
Okay, so she's what?
Not the one.
She's not the one, I get that. So we're gonna move on, just so we can get through all of the examples, and then hopefully you'll have homework time, and then during the homework time, I'm more than happy to help you on individual problems. Okay?
We're doing all of them today.
Well, we don't have that many examples left.
How many is it?
Left, 3. I wasn't kidding when I said we were almost done. Okie dokie. This is just a fancy way of saying we're going to use the quadratic formula and we're going to have a complex answer. That's it. So the key here is that I do not want a decimal because I said simplified radical form, which is what we've already been doing. And I expect that I'm going to have an I in here somewhere because that's how we create a complex answer.
Or is it something completely different?
Well, it's something that you should have noticed in the notes because it was what we did the first day.
Yeah, if you look at it.
So if not, you're going to want to play catch up here. Okay. So to start with, this is not factorable. And I keyed you into that when I said find the complex solutions. So I'm going to have to use the quadratic formula. In order to use the quadratic formula, I have to know my A, B, and C values, correct? What's my A value? What's my B value? And what's my C value? So I take those and I plug those into my quadratic formula. If you can't remember what it is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we take this and we plug them into that. When I do, I get -5 plus or minus the square root of 5 squared minus 4 times A times C all over 2 times A. So I just plugged in those A, B, and C values. Then I'm going to go ahead and I'm going to simplify. So I have -5 plus or minus the square root of 5 squared is 25 minus, we are paying attention, right? 4 times 5 times 6. What is it? 120. All over 2 times 5, which is 10. You can do it on a calculator. That's the beautiful part. So I simplify it again. I get -5 plus or minus the square root of 25 minus 120 leaves me with -95, still over 10. We're going to pause here and let everybody catch up. If you were not here the first day or you haven't watched the videos for that first part of the lesson, you're going to want to pay attention. Hold on. There's a reason for that.
I ain't smart enough to work the calculator, so I can't do it.
No, you plugged it in correctly. However,
It says deep.
say it again. One more time so they can hear you.
It's a negative.
Come on.
Wait, wait, wait.
Say it.
It's a negative square, so it's not allowed to be a negative square.
Okay, we can't take the square root of a negative number because no number times itself is going to equal negative. So I can't do this until that 95 is positive. What's the only way to make that 95 positive?
Make an eye.
Put an I out front. The I out front will cancel out the negative under the square root. So this becomes -5 plus or minus I times the square root of positive 95 over 10. So putting an I out front cancels out the negative under the square root.
Where are we getting this from?
Well, if you weren't here the first day. So somebody way smarter than us and with way more time than us figured out that if I have the square root of a negative, I can separate that into the square root of -1 times the square root of that positive version. And I'm just using I to represent the square root of -1. Because it doesn't exist in my number system, but that doesn't mean it doesn't potentially exist.
Did you put
Say that again, hon.
I feel
No, I cannot go in the calculator, which is why we just leave it out front.
math is 85%.
People just making up stuff. Yeah, absolutely.
Why would they do that to the world?
Well, there's a reason behind it. They don't just make it up to be like, I'm going to mess with kids 30 years from now.
This
No.
problem isn't solvable. Just kidding.
It's just not solvable in our number system. It doesn't mean it couldn't potentially
I
exist.
think there should be one number system.
Okay, so let's go ahead and finish this out. What do I need to do next? Factor tree the square root of 95. What multiplies together to get 95? 5 and what? 5 and 19? Both of those are prime, which means the square root of 95 is not going to reduce to anything, so it just stays the square root of 95, which also means since there's no number out front, I cannot cancel out anything from this 5 and the 10. We can only do that if there are 3 whole numbers around. So this is my final answer.
That's beautiful.
Can it get harder? Would you like to see my calculus lesson for today?
Yeah, do one.
Yeah,
Just
show
do one
us.
real quick.
I'll do one at the end.
That'll tell me
Just
if I
for
can
fun.
stop taking that.
I listened to it.
Yeah, it's fine.
You what?
I listened to it.
That's true.
Everybody's like crying.
Oh yeah, no, I gave a test last week and a girl openly sobbed when she saw it.
See, I don't want to say I got to
I don't relish that, but
She's like next time crying.
I do not actually. I feel very bad. Okay, let's go ahead and do our last 2 examples, then it's homework time. So doing the same thing, but this time using the quadratic 8n squared plus 10n plus 25 equals 5.
Subtract 5.
Hold on. Let's give everybody a chance to write it first, and then Heath, I'll let you start us off. Heath, go ahead.
You have to subtract the 5.
Because I need everything on the left-hand side. So when I do that, I get 8n squared plus 10n plus 20 equals 0. You could try to factor this if you want to, but it's not going to work. So what we're going to do instead is the quadratic formula. You can plug your A, your B, and your C, and then plug them in. When I plug them in, I get negative 10 plus or minus the square root of 10 squared minus 4 times my A value of A times my C value of 20, all over 2 times my A value of 8. We're pretty sure that we're going to get another negative under the square root, so don't try plugging that whole thing into your calculator.
I thought the negative 10.
It's negative 10?
Yeah.
Only if it's under the square root.
Oh,
So-
it's a negative 95.
Right. Yeah. So I go ahead and I simplify this. I get negative 10 plus or minus the square root of 10 squared is 100 minus, what's 4 times 8 times 20?
4 times 8 times 32 times 20.
640.
If you give me
Right.
2 seconds, I want to say that. 32 times 20.
100 minus 640.
Negative.
Negative 540.
This is what
So I get negative 10 plus or minus the square root of negative 540 over 16. What is the first thing I do when I see that negative under the square root? Put an I out front and get rid of it. So I get negative 10 plus or minus I times the square root of positive 540 all over 16.
16.
And then I factor treat 540.
Letters should not even go. Just mess it up.
So I take 540 and I break it down. What multiplies together to get 540?
Oh,
I don't know what a calculator
it'll
would
be
be.
like some of the 9 and 5.
How about 9 and 60?
9.
Okay.
Well, in my head, I'm thinking like
So
I'm trying to get
close.
to 54, not 540.
Yeah. Okay, so 9 and 60, neither of those are prime. So I break them down farther. 9 breaks into 3 times 3. What does 60 break into? 10 and 6, okay. Neither one of those are prime, so I have to break them down again. 2 and 5 makes 10, and then 2 and 3 makes 6. So now I have my prime factorization, which is 2 times 2 times 3 times 3 times 3 times 5. What do I do from here?
Combine like terms.
Okay, put matches together. 2 and 2 makes 4. 3 and 3 makes 9. That 3 and that 5 are kind of standalone now. I can put them together. Nothing else combines. So I have 4, I have 9, and I have 15. Square root of 4 is 2. Square root of 9 is 3. Square root of 15 stays the square root of 15. I can put the 2 and the 3 together to get what? 6. So this becomes 6 square root of 15, which I will then replace the square root of 540 with. So now I have negative 10 plus or minus 6i times the square root of 15 over 16. Remember, the I goes directly in front of the square root, so it goes after the whole number. And then I ask myself, what can I take out of 10, 6, and 16? 2. 10 divided by 2 is 5. 6 divided by 2 is 3. 16 divided by 2 is 8. So I'm left with negative 5 plus or minus 3i root 15 over 8. And that's my final answer. That's- Say that again. You can separate it into two answers. I'm more than happy to accept it like this though. No, I just looked to see that happened here. That doesn't always happen. I just looked for a common factor between the three of them. Yeah, that just happened to work here. Okay, we have one more and then we are finished. Are you guys super duper excited?
Not really, but
I know you are.
let's do it anyway because I'm curious.
On your own, please work through this as far as you can go. Shh. On your own, please work through this as far as you can go.
No, please.
Those people who are talking right now are probably the ones who never call. Eli, where do I start? Okay. So I get 10p squared plus 10p plus 11 equals 0, right? I mean, you did it backwards.
I took the 10s.
That's, you can move technically all of those over to the right hand side. It's still going to work out. That's okay. I hate having that many negatives, so if I can avoid it, I definitely do. Okay, what do I do next? Eli, you're still up. Quadratic formula, yeah. So when I do, what do I get? Like, what is my quadratic formula with the numbers plugged in?
Why don't they are like 8?
So negative 10 plus or minus the square root of 10 squared minus 4 times A times C all over 2 times A. I simplify inside of the square root and I get what answer? What do I get under the square root? Do the 10 squared minus the 4 times 10 times 11.
Negative 340.
Negative 340. So I have negative 10 plus or minus the square root of negative 340 over 20. Hannah, what do I do?
No. Negative 10. Also minus
Gotta put the I out front to get rid of the negative underneath the square root. There you go. And now what do I do next? So factor tree the 340, right? Okay. So let's factor tree the 340. Cool, what multiplies together to get 340? 17, 20. You're very good at mental math. 17 is prime, 20 is not. So what can I break 20 down into? And then 10 breaks down into 2 and 5. So I have 17, 2, 2, and 5 as my prime factorization. Yeah, back there by the whiteboard. Yeah, but you're still going to end up with the same prime factorization. Yes. How do you did what? That's fine because the 17 and the 5 are going to come back together. So it's going to end up equaling the same as long as all your work is right. Okay, so I noticed that I can put 2 and 2 together to make 4. And then I have 2 stragglers, 17 and 5. I can go ahead and put those stragglers together just to make my life a little bit easier. And what I do, I get 85. So I have 4 times 85. I square root both of those. Square root of 4 is 2. Square root of 85 stays because there's nothing perfect square-wise I can take out of that. So I come back here and I have negative 10 plus or minus 2i square root of 85 over 20.
Take 2 out of all the numbers.
I can take a 2 out of everything, and I'm left with negative 5 plus or minus I times the square root of 85 all over 10. And that's my final answer. How do we feel about that?
Okay. I think I'm picking up what you're putting down.
Sweet. That's what I like to hear. Okay, so your homework is on Canvas. Hopefully you all have been working on it at least a little bit up to the point. You should be able to finish it out. You have the rest of class, which is about 21 minutes. So you guys can ask me questions as you work through it. This, I'm pretty sure we're going to take a day in class tomorrow to work on it as well. I can't promise that, but that's what I'm thinking is going to happen. Just to make sure you truly understand it before we move on. Okay? I don't know about that.
What do you